Hello, ladies and gentlemen. I'm going to step us through a little bit about transformations of functions. So on your screen, you see an x cubed function. So this is the plot of y is equal to x cubed. So for any input of x, for example, a positive 1, if we put a positive 1 into the function y equals f cubed, then we're going to get the answer y equals 1. So that is consistent with this point right here. On the other hand, if we put in negative 1 as the x value for the function f of x equals x cubed, then negative 1 times negative 1 times negative 1 will also give us a negative 1. So that's consistent with this plotted point of negative 1 comma negative 1. So let's go ahead and see what would happen if we transform this parent function by adding 7 to it. Hopefully you remember in class that whenever we add 7 to a function or a number to a function, if we add to that function without intruding on the operation itself, that it just slides this function up. If we subtract, it slides the function down. So let's go ahead and activate that one and have it be on the screen. Ooh, that looks like a problem until we get in here and zoom out and we can see all that happened was that our purple curve is exactly the same as our red curve. It simply slid up to a position of 0, 7 as this point of inflection in the middle of the curve. So this made sense. Our x cubed curved was translated up the y-axis of positive 7. Okay, that's good. Now let's look at what happens if we make a change in this equation by putting the number inside of the operation. So this is x minus 10, the whole quantity cubed. When we did this in class, what we learned was that by putting a number inside like this, then that means that it will move the function side to side along the x-axis. And it does something strange to this negative sign. We would expect if we see a negative sign that it's going to move it in the negative direction, but it doesn't. It will move it in the positive direction. So that's why we say it's a liar. It's lying. It says negative, but you're supposed to move it in the positive direction. So we're going to plot that one, and we would expect to see this original parent function. Remember, we're going to look back at the red graph only. We expect to see this original parent function move 10 units, but move in the positive direction. So let's see if it does that. Oh, happy day. It certainly did. So our parent function in red is matched with this function in blue, and the function in blue is the quantity x minus 10, all of that quantity cubed. All right, so that makes sense. Now, the next thing that we're going to do is we're going to combine these two functions. So notice I have x cubed plus 7 still on the screen in purple, and I have x minus 10, the full quantity cubed, and that's here in blue. If we put all of that into one step, and we say that we're going to take the x cubed, the x minus 10 quantity cubed, and add 7, it's kind of easy if we start at this one to see what's going to happen. If we start with this one right here, that's this function, we would expect it to just move up 7. So let's see if that's what it does when we do. Oh, happy day, it did. So math is a beautiful thing. That was very predictable. So this one that's in black is this more complex function right here where we have multiple transformations of the original x cubed function. Now, the next thing that we're going to do is we're going to do a reflection. So I've put a negative sign in front of this whole function, all right? So I'm taking this entire function that's in black, and I put a negative sign in front of it. And if you recall from the notes that you took in class, when you have the negative sign in front of that function operation, it reflects that function around the x-axis. So if we do that, sure enough, that's exactly what happened. It took this black line, which is this function right here, and it reflected it about the x-axis. So this one down here that's kind of another one that's kind of reddish orange, this one is the function that has 3 transformations. It's an x cubed minus 10 cubed plus 7 and then reflected around the x-axis. So lots and lots of steps. We started with this function right here, all right? So hopefully some of that makes sense. Kind of a lot of steps there.